Alright, Danny, here we go. I'm going to try this again. So I'm doing this by myself this time, so I'm going to try to use the zoom in and out to try to navigate what's going on with the problem. This is the problem with the two boxes, different weighted. You got a 3 kilogram box on a triangle on a vertical, on an inclined plane, and a 2.5 kilogram box suspended vertically from a pulley. So the question is, what direction and at what speed do these boxes accelerate? And 2, what is the tension of the string? So we'll break these in two. This is going to be part 1. In this one, we're going to do the direction of the boxes and what speed or what acceleration. Alright, so you got these two boxes, 2.5 kilograms suspended from midair, and 3 kilograms. That one is on that inclined plane. So we need to figure out what is the net sum of the forces that these boxes are making. The first one's easy. We'll just do box 2, suspended from air. The force of that box is equivalent to its weight. So we know the weight is the mass times the gravity equals weight. 2.5 times 9.8 equals 24.5. So that box is generating 24.5 newtons of force pulling downward towards the ground. All right, or tugging on this system, on this mechanism, I should say, I guess. All right, so we figured out what the force generated by box 2 is. Now we need to figure out the force generated by box 3. Now, box 3 is sitting on the inclined plane, so part of the force, gravity is acting on this box. So we can't as easily just say, okay, we're going to take the weight of this box, and that's what's pulling on the system, because only a fraction, only a portion of it is pulling on the system, because the inclined plane is absorbing part of it as well. So we need to figure out what force is being acted on, and then we can figure out how much force is being generated by it, or what its weight is. Alright, so we take that 3 kilogram triangle. We got this triangle, and we're going to say the angle's 37 degrees. The hypotenuse is 3 kilograms, the weight. And we're going to make this little triangle. We want to figure out the x component of this. So we're going to solve by using cosine. So we know that the cosine of the angle, cosine of 37, is equal to the side adjacent over the hypotenuse. So cosine of 37 equals x over 3. I'll try to show it a little wider screen. Okay, so you got this triangle, you got this angle, it's 37 degrees. We're trying to solve, we want the y component. Alright, so I'm just going to try to edit this out. Alright, so, okay. Edit it out, retake, start now. So we need to figure out what force of this box is being acted on in this system. So the box is being pulled down by gravity, but not the whole 3 kilograms of the box, only a portion of it. So we figure that out by calculating the y component of that 3 kilograms. What's the vertical component of that angle, the 3 kilograms that's on that 37 degree angle? So we got this triangle here. It's a right triangle. The angle's 37 that's coming off that. We want to figure out the y component, so we're going to use the sine. So the sine of 37 equals y over 3. Okay, we got this down here at the bottom. So this one I've actually already solved out for us. So if you read it without the parentheses, picture without the parentheses, the sine of 37 equals y over 3. To solve that, we multiply both sides by 3, so those 3's cancel. And the sine of 37 times 3 equals 1.8. So the y component is 1.8. So let's go back. What did we just figure out? We just figured out the y component of this triangle. The 3 is in what unit of measurement? It's in a kilogram. So the unit of measurement that we have right now, the 1.8, is in kilograms. We know that the vertical component of that box is 1.8 kilograms. That's how much it's weighing. That's how much it's being acted on by gravity. So now to figure out the force or the weight of that box that's being acted on, or the force down, the weight is going to be equivalent to 1.8 times gravity times 9.8. So I think I did that one up here. 1.8 times 9.8 equals 1764. Okay, so the weight is 1764. So the two forces acting on this object, box 1, weight 1764, box 2, 24 and a half. So we need to take the difference of those two to see what the net force is. So the 24 is bigger. That box 2 is going to pull this system down. The system is going to accelerate down from box 2 towards the ground. All right, so it's going to do so with a force of 24.5 minus 17.64, which I calculated out to be 6.86. Okay, so that is, let's see what we figured out first. And then now the answer is right at our fingertips. So we just figured out what the net force of this whole system is. We figured out that it's got a 6.86 Newton force going down. So now to figure out the acceleration, it's simply force equals mass times acceleration. Force, 6.86, equals mass, and this is the mass of the system, 3 kilograms plus 2.5 kilograms, the sum of the two boxes, times A. As we solve that out by dividing both sides by 5.5, the acceleration is 1.2 meters per second squared. Okay, I hope that made sense.